Hello everyone, welcome to a new video of Physmatica. Before we start, please like and subscribe. This problem is a very interesting problem. It's not difficult at all. The calculation is middle school, not even high school, but the intuition behind it is not that clear and might not come very quickly to everyone. And it just shows that how our intuition is wrong regarding geometry and overall in some mathematical concepts. The problem is that imagine a rope wrapped tightly around the Earth's equator. Now imagine you add just 1 meter to that rope. What is the size of the gap formed between the Earth and the extended rope? So think about it. How much do you think that would be? Like a millimeter, 1 centimeter, 10 millimeter? Like without calculation, when I was thinking about it, I was thinking that so you have planet Earth and the circumference is almost 40,075 kilometers, and you have this rope wrapped around it and you add just 1 meter. How much that even affects it? Like imagine the rope is floating now over the Earth, around the Earth, and it's floating. It would be like, I was thinking maybe 10 millimeter. So you have this at the start, which is tightly wrapped around the Earth. Then you add 1 meter to it, and we want to find the gap. Let's just do the calculation and still think about it before we do anything. Think about what is your intuition regarding this? So we know that the circumference is 2 pi r simply, and we just add 1 meter to it. So what we want is simply big R minus R. We want to find the gap, and that's the gap. So let's just do that, and we get 1 over 2 pi. And 1 over 2 pi, it's almost 16 centimeter. And this is actually shocking because that shows that we can actually slide our hand between planet Earth and that rope. And that is not coming very quickly and clean as an intuitive thought. And the reason behind this is that because circumference increases linearly with radius, and that's the main point here. And because of that, this happens, and this is a general solution if we do not consider the changes in the rope. And another thing is that the object itself has to be completely convex, no dent in it or something like that, and the rope itself should be completely good, so there is no change in tension or anything. But if we put those aside, this is a general solution, and doesn't matter if it's a basketball or if it's the sun or even any object, it's always this amount, and it's always like this. And this just shows that how wrong our intuition is, and this is one of the simplest and one of the primary problems that you could think about. And there is much more than that I'm going to discuss later, but this one was actually interesting to me because it doesn't need any calculation, and when you just think about it, doesn't come very clear if you do not think about it as for example, a basketball. If you think about it just as a planet and saying that you just add 1 meter to that planet, that is the rope around it, and the answer is actually 16 centimeter gap in the end, which is amazing and very interesting. I hope you liked it. Thank you.